Yes, Romex, specifically NMB wire, is suitable for wiring fluorescent lights in a church, even though it's not a residential building. Romex is accepted for general-purpose wiring in both residential and commercial structures, churches included. Regarding EMT, or electrical metallic tubing, while it's not strictly mandatory for wiring outlets and switches with Romex in a residential context, it's generally advisable for commercial applications such as churches. EMT offers enhanced protection against physical damage and potential tampering, which is especially important in public spaces. For wiring fluorescent lights, you have the option of using either Romex or EMT. EMT is often favored in commercial settings where the lights are exposed to possible damage or where greater rigidity is needed. When wiring fluorescent lights in a church, adherence to the National Electrical Code, or NEC, and any local building regulations is crucial. The NEC outlines specific requirements for wiring fluorescent lights. Firstly, use the correct wire size for the circuit load. Secondly, install a junction box at each location where wires are joined or tapped. Thirdly, secure wires properly using approved methods such as cable clamps or straps. Fourthly, use ground fault circuit interrupters or GFCIs where they are required. In addition to these code requirements, it's essential to follow best practices for wiring fluorescent lights in a church. 1. Use Romex or EMT that is specifically rated for the intended application. 2. Route wires through conduits or cable trays to protect them from damage. 3. Label wires clearly for easy identification. 4. It's highly recommended to hire a licensed electrician to inspect and approve the wiring to ensure safety. In summary, Romex can be used for wiring fluorescent lights in a church, even if it's not a residential building. However, it's advisable to use EMT for outlets and switches in commercial applications. Consider using EMT for the lights as well to provide added protection. Always comply with code requirements and follow best practices to guarantee a safe and compliant installation. Now let's delve into some of the technical aspects. When selecting Romex or NMB cable, ensure it is rated for the voltage and amperage requirements of the lighting circuit. Typically, for general lighting circuits, 12/2 or 14/2 NMB cable is used, but always refer to the fixture specifications and local electrical codes. The first number, 12 or 14, refers to the American wire gauge, or OG, of the conductors, and the second number indicates the number of current carrying conductors plus the ground. It's crucial to calculate the total load of the fluorescent lights. Each fluorescent light fixture has a specific wattage, and you need to sum the wattage of all the fixtures on the circuit. Then, divide the total wattage by the voltage of the circuit, typically 120 volts in many commercial settings, to determine the amperage. Ensure that the circuit breaker or fuse protecting the circuit is appropriately sized for the load and that the wire gauge is sufficient to handle the amperage without overheating. Regarding the installation of junction boxes, the NEC requires that all electrical splices and connections be made inside approved enclosures, such as junction boxes. These boxes protect the connections from physical damage, dust, and moisture and help prevent electrical fires. When using Romex, secure the cable to the junction box using cable clamps or connectors specifically designed for an NMB cable. These clamps prevent the cable from being pulled out of the box and protect the wires from abrasion. When using EMT conduit, use appropriate connectors to attach the conduit to the junction box. EMT provides a continuous metallic pathway for grounding, which is an important safety feature. The NEC specifies grounding requirements for electrical systems to ensure that metal parts of equipment are properly grounded to prevent electric shock hazards. In commercial settings, it's often required to run a separate grounding conductor with an EMT conduit in addition to using the conduit itself as a grounding pathway. When installing fluorescent lights, pay close attention to the mounting height and location of the fixtures. Ensure that the fixtures are securely mounted to the ceiling or wall and that they are not likely to be damaged by impact. Consider using wire guards or protective covers to further protect the fixtures in areas where they are exposed to potential damage. The NEC also specifies requirements for the spacing of lighting fixtures to ensure adequate illumination levels. Refer to the Illuminating Engineering Society, or WISE, recommendations for specific lighting levels based on the type of activity that will be performed in the space. When wiring switches and outlets, use appropriate wiring methods and devices that are rated for the intended application. For switches, use switches that are rated for the voltage and amperage of the circuit. For outlets, use grounded outlets that provide a connection to the grounding system. In commercial settings, it's often required to use tamper-resistant outlets to prevent children from inserting objects into the slots. When installing GFCI protection, it's important to understand where GFCI protection is required by the NEC. GFCI protection is typically required in wet locations such as bathrooms, kitchens, and outdoor areas. It is also required in locations where there is a high risk of electric shock, such as construction sites and healthcare facilities. GFCI devices monitor the current flowing in a circuit and quickly interrupt the power if they detect a ground fault, which can help prevent electric shock injuries. When labeling wires, use wire markers or labels that are durable and easy to read. Label each wire with its circuit number and function. This will make it easier to troubleshoot the electrical system in the future and prevent confusion when making repairs or modifications. When hiring a licensed electrician, verify that the electrician is properly licensed and insured. Ask for references and check their online reviews. A qualified electrician will have the knowledge and experience to safely and correctly install electrical wiring in accordance with the NEC and local building codes. Remember, electrical work can be dangerous, so it's always best to consult with a qualified professional if you are not comfortable performing the work yourself. Now let's discuss specific NEC articles that are relevant to this scenario. NEC Article 300.3 covers conductors. It states that all conductors of a circuit, including the neutral and equipment grounding conductors, must be contained within the same raceway cable or enclosure. This helps to minimize impedance and reduce the risk of voltage drop. NEC Article 310 covers conductors for general wiring. This article specifies the allowable ampacities of conductors based on their size, insulation type, and ambient temperature. It also provides guidelines for directing conductors when multiple conductors are installed in the same raceway or cable. NEC Article 314 covers outlet, device, pole and junction boxes, conduit bodies, fittings, and handhole enclosures. This article specifies the requirements for the size and construction of these enclosures and the methods for securing them to the building structure. NEC Article 410 covers luminaires, lamp holders, and lamps. This article provides requirements for the installation of lighting fixtures, including the support, wiring, and grounding of the fixtures. NEC Article 518 covers places of assembly. This article applies to buildings or portions of buildings used for the gathering of 100 or more persons for deliberation, worship, entertainment, eating, drinking, or similar purposes. Churches typically fall under this category. It includes requirements for emergency lighting, exit signs, and fire alarm systems. When selecting an EMT conduit, choose the appropriate size based on the number and size of the conductors that will be installed in the conduit. Use conduit fill tables provided in the NEC to determine the maximum number of conductors that can be installed in a given size of conduit. When bending EMT conduit, use a conduit bender to avoid kinking or flattening the conduit. Follow the manufacturer's instructions for using the conduit bender. When cutting EMT conduit, use a hacksaw or a pipe cutter to make a clean, square cut. Remove any burrs or sharp edges from the cut end of the conduit to prevent damage to the conductors. When installing EMT conduit, support the conduit at the intervals specified by the NEC. Use conduit straps or clamps to secure the conduit to the building structure. Ensure that the supports are strong enough to support the weight of the conduit and the conductors. When making connections to EMT conduit, use appropriate fittings such as couplings, connectors, and elbows. Ensure that the fittings are properly tightened to provide a secure and watertight connection. When pulling wires through EMT conduit, use a wire pulling lubricant to reduce friction and prevent damage to the conductors. Use a wire pulling grip or a wire pulling machine to pull the wires through the conduit. Avoid pulling too many wires at once, as this can cause the wires to become tangled or damaged. When terminating wires at devices, use appropriate terminals or connectors that are rated for the size and type of wire being used. Ensure that the connections are tight and secure to prevent loose connections, which can cause overheating and electrical fires. When testing the electrical system, use a multimeter or other testing equipment to verify that the voltage, current, and resistance are within acceptable limits. Test the continuity of the grounding system to ensure that all metal parts of the equipment are properly grounded. When troubleshooting electrical problems, start by checking the circuit breaker or fuse to see if it has tripped. If the breaker has tripped, reset it and see if the problem recurs. If the problem persists, use a multimeter to check for voltage and continuity in the circuit. Look for loose connections, damaged wires, or faulty devices. Finally, always prioritize safety when working with electricity. Wear appropriate personal protective equipment, such as safety glasses and gloves. De-energize the circuit before working on it, and use a voltage tester to verify that the circuit is de-energized. If you are not comfortable performing the work yourself, hire a qualified electrician to do it for you. The NEC is updated every 3 years, so it's important to stay current with the latest code requirements. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA, or access it online through various subscription services. In addition to the NEC, there may be local building codes or ordinances that apply to electrical installations in your area. Check with your local building department to determine what codes are in effect. Remember, electrical codes are designed to protect people and property from electrical hazards. Following these codes and best practices will help ensure a safe and reliable electrical system.